Hey everybody, my name is Mike Nomich and I'm the product manager for Nomad at HashiCorp. Today I want to talk to you about a new tool that we're really excited about, which is called Nomad Pack. It's a new package manager and templating tool for Nomad. In this talk I want to give you an overview of what Nomad Pack is. I want to go over the various ways that you could use Nomad Pack within your organization. And then I want to dive into the structure of what is in each Nomad Pack. And then we'll go over the process of taking a Nomad Job file and turning it into a pack that could be consumed by anybody. So by the end of the talk, you should have a good sense of what the tool is, how you can start using it, and how you can contribute to the pack ecosystem. All right, so let's jump into it. So what is Nomad Pack? Nomad Pack is a CLI tool that can be used either in your terminal or in a continuous integration pipeline. And it sits between registries and a Nomad cluster. In these registries, we have Nomad Packs, which are groups of templatized job files and variable definitions. Nomad Pack will pull down a pack from one of these repositories, allow a user to input variables, and then send these job specs to the Nomad cluster to run them and manage them over time. So in this example, we have two GitHub repos. One could be public, the other could be private. And to GitLab repo, Nomad Pack will pull these packs down and then send jobs to Nomad, in this case, running Traefik, Jenkins, and Postgres. So let's go quickly over what it looks like using Nomad Pack. So right now I have a Nomad cluster, and I have Nomad Pack locally. So if I run this CLI command, I can see the various commands that I can run. And right now I'm going to list out the various packages that I can deploy. So I use the Nomad Pack registry list command. And so this shows me all the packages that I can deploy. This right now is pulling from what's called the Nomad Pack community registry. So this is a public registry that anybody can contribute to, and we really encourage people to contribute to it. So you can open a pull request, and then your pack will be added to this list. And then when people use Nomad Pack in the future, by default, they will have access to the pack that you've written. So this is what we have right now as options to deploy to Nomad. So I look at this list and I say, okay, I can deploy some cool things. I could deploy Traefik, I could deploy Nginx, I can deploy Prometheus, but for the purposes of this demo, let's just deploy Hello World. So I'm going to copy that. And the first thing I want to do is see, okay, what are the options that I could pass to the Hello World pack? So I will run the info command, Nomad Pack info Hello World. I run this, it gives me a brief description of what this pack does, deploys a simple application with an associated Consul service, and it gives me various variables that I can pass into the package so that when it's deployed to Nomad, I can customize it for my own needs. In this case, we'll just focus on the message variable. So now the next thing I want to do is see, okay, what are the jobs that this would be deploying to Nomad? Each pack can have one or many jobs that it deploys to Nomad. And so let's see what that looks like. For that, I'm going to use the render command. So I'm going to say Nomad Pack render hello world. And now this puts out what the Nomad job spec that this pack defines looks like. So I get a sense of what it's doing. I say, okay, this is a server, a service task. It's a Docker driver, and it's using this mnomich hello world server with this environment variable, hello world. Now the important thing about packs is that everybody can use them how they want by passing in variables. So I saw that there was a message variable. So now if I pass in the var message equals something, let's say hola mundo. Now when I render this file, oops. There we go. Now when I render this file, this message says hola mundo. And now that's a very simple variable that we could pass in, but as we go, we'll see that we could get really complex with the logic that we insert into packs. So now I have an idea of what this is doing. I can now test what this looks like against a Nomad cluster. So I'm going to run this Nomad Pack plan command, and this says that this will deploy a single job to Nomad, and it would be successfully allocated. All right, so it's time to actually deploy this. So now I use the Nomad Pack run command. I give it my hola mundo message. I guess it doesn't like exclamation points. All right, and now it says the pack is successfully deployed. And now what I could do is I could check the status of this pack. I can make sure it's up there. This now lists all the packs that have been deployed to Nomad, the status command. And if I want the status of a specific one, I can check Hello World. And this says I'm running the latest deployment of Hello World. It has a single job called Hello World, and it is running. So let's check that out in Nomad. All right, so now if we go to Nomad, we see that the Hello World job is running. If we click into it, we see that it's a pack, and we see some pack details along with the standard job details. So we see that this pack's name is Hello World. It's coming from the default registry, and it's the latest version of the pack. And then if we jump into the actual server that was deployed at the port it's deployed on, here we see that it's saying Hola Mundo. So we properly took a variable from the CLI, we passed it to Nomad Pack, that put it into the Nomad Job for us, and then it deployed properly. So that's a really simple version of running Nomad Pack with the simplest possible pack. Now you could do this with a ton of different jobs and really quickly with a few keystrokes be deploying common applications like WordPress, like Nginx, like HA Proxy to Nomad. Now let's jump into the details of what is actually in a pack and how do you make one. Okay, so right now I have opened the Hello World pack directory. So this would be the directory that gets pushed up to the community registry so that other people can use this Hello World pack. So let's just jump into the contents one by one and we could explain what's in there. As a brief overview, we'll have a README, a metadata file, a variables file, and then an optional outputs template. And then also we'll have the actual template that makes up the job spec and potential helpers. So first, let's check out the README. So in the README, when you're writing a pack, you're going to want to write a very simple description of what your pack is, and then how one would use it, and then also call out any integrations or dependencies. So here I say that there's an integration with Consul, and so that someone who uses this will know, oh, I will need Consul up and running to potentially use parts of this. And then I call out other integrations that this has so that people could really use it successfully. I'd say in your README, just try to set up whoever the end user is for success. And then also, we have a list of variables that can be used, and this gives people a general idea of how they could customize this application for their needs. So that's the README file. Now let's jump into the metadata. So this metadata defines some general information about the app, what the URL of the app itself is. So if this were, let's say, WordPress, this would point me to the WordPress homepage and the WordPress author. And then this pack stanza says, this is the name of the pack, gives a general description, and then a version. And so if I were to, run Nomad Pack info, it would be pulling this data from the metadata.htcl file. Also in the metadata file, you can call out pack dependencies. So we won't go into this in detail in this talk, but packs can depend on other packs. So you could have, let's say, reusable code to keep your packs dry in some sort of helper pack, and then inherit from that in a variety of other packs. So that's the metadata file. Now let's jump into the variables file. So if you're used to Terraform, this will look really familiar. We tried to model it based on the variables that you see in Terraform, and this is running with HCL as well. So here we have, there's a job name variable, a region variable, a data centers variable, account, message, whether or not to register a Consul service, et cetera, et cetera. And now whenever I run this pack, I could actually pass in different values for each of these variables. So we saw earlier, I passed in the message of Hola Mundo. It overrode the default Hello World, and then that rendered that to the screen. In this pack, I see by looking at the variables file that I could pass in a different count. So I could potentially run 10 of this pack, and then I could also say whether or not to register a Consul service and what that Consul service's name is. So it's really important when you write a pack to figure out what you want to create variables for, how you want to parameterize the pack. I would say that it's important to strike a good balance between parameterizing too much or too little. If you parameterize too little, it's really not that useful of a pack. You might as well be sending somebody a job file and having them figure it out from there because they can't customize it to their own needs. If you parameterize too much, it's also not that helpful because they have 50 variables to read and try to figure out how to actually use the job. So I try to strike a good balance there. So that's the variables file. And then lastly, we have the actual templates themselves that define the Nomad job specs. So these are created in the templates directory, and any job that you want to deploy to Nomad as part of a pack gets a .nomad.tpl extension at the end of the file name. So if I had multiple jobs that this pack wanted to deploy, I would say name of job.nomad.tpl. Let's jump into the hello world job. So this job, you can see, looks roughly like a normal job spec, except you'll see some delimiters, the open brackets and the closed brackets. And we'll get into that in a second. But you see that normally it looks like HCL, except for that. Now, Go template is what's being used with these delimiters. So whenever I open a double bracket, it says that I'm using the Go template templating language here. This allows me to do things like inject variables. In this case, I'm injecting the message variable. It allows me to do things like call helper functions. So here I'm using the quote helper function that says I'm going to take this message and pass it into quote, and then it's going to render that into the job spec. So in this case, it's going to take whatever my message is, wrap it in quotes, and we'll have message equals quote. So that's a really simple use of Go template, but we have actually more complex uses. So here we have some conditional logic. So this is saying if this variable exists, then render anything in this block to the HCL. So now I could get a little more complex. I don't just pass variables in, but I could actually, completely omit or skip certain stanzas. There's also the ability to use helper templates. So here in Go template, we're using this region template, and we'll see what that looks like here. All right, so this is the helpers file. And what this does is it defines templates that can be used elsewhere in your code. So for instance, if you had, let's say, a Consul health check that knew that every job was going to be using, you could define a Consul health check template and then insert it into various jobs. In this case, we have two very simple templates, one that defines the job logic for a job name. If the job name is equal to nothing, give it the name of the pack, and otherwise pass in the job name variable as the name of the job. And here we have another one, the region template that says, if the region is not equal to empty string, insert the region value here. And so this logic gets inserted right here into the Nomad job spec. All right, so really quickly, let's see this in action. Let's use the register Consul service variable. So if I am the author of this job, I can use the render command to see what this job spec looks like. So I'm going to give it the render command with the var register Consul service true, and we can test out the Go template logic. So I do this and I see that, hey, yes, this service is being rendered. So everything in here was properly rendered. Now if I give it a false value instead, we see that the Consul service was not rendered in the job, and when this gets pushed up to Nomad, no Consul service will be registered. So that's a really simple use of Go template logic to parameterize values and pass in variables into packs so that you can customize them for various use cases. All right, so now that we know, what the contents of a pack are, how to use Nomad Pack generally, let's go through the process of actually writing a Nomad Pack ourselves. So the application that we're going to packify is something called Nextcloud, which is a productivity suite. It can kind of be thought of as an open source, self-hosted Google G Suite or Google Drive. We're going to take that in Nomad Job spec form, and we're going to convert that to a Nomad Pack. So at the end of all of this, what we want to do is push something up to the community such that anybody now can go install Nomad Pack and say Nomad Pack run Nextcloud and get this productivity suite up and running on their self-hosted cluster. This is something that's been really popular for people who run home labs or are really into self-hosting, but it's also something that's also often used by big enterprises if they want an alternative to G Suite. Okay, so let's get into it. All right, so here are the basic steps to writing a Nomad Pack. First, you want to start with a Nomad job spec, and we're going to assume that you know how to do that. If you don't know how to do that, there's some resources online. You want to start with something that you can push up to Nomad with a Nomad run command yourself, and then we'll work from there. Then you want to get some basic scaffolding. We'll show you how to do that. Then you want to input the metadata and the README information for future users. And then you want to go through this process of identifying parameters. So these are all the things that could be variables in your Nomad Pack. And you want to figure out, okay, what are the things that I actually care about allowing people to customize in this pack? Then we are going to go through each of those parameters and parameterize the template. We're going to make a variable, and we're going to pass that variable through to the templates and conditionalize what we need to conditionalize, input the values where we need to input them. So we do that for each of these parameters. Then we're going to test our pack locally. And then lastly, we're going to contribute by pushing up to the Nomad Pack community registry. All right, so let's start with our Nomad job. And I'm coming into this with this job already written. And let's go through it really quickly just to see what it contains. So it's job Nextcloud, has some basic information on region, data centers, namespace, etc. It has a constraint that says that it will only run on Linux. And then it has a task group. And this task group has a couple of tasks within it. They are connected via a bridge network, so that means they share a network namespace. We have a couple ports that are static, and this is because I know that the virtual machine I'm running it on has these exposed. So I want my HTTP port to be exposed on 4001, and my DB to go to the Postgres port that's conventionally 5432. Then I have my application. This is running Nextcloud's latest image. It mounts a volume from this directory on my host to this directory within the task. This is conventionally where Nextcloud expects this information to be. It has a resource stanza, and then it has some common environment variables. Now, Nextcloud can be run with a Postgres database or a MySQL database. In this case, we're running a Postgres database, so we have these environment variables exposed. As you can see, it's very secure. And then we have the database task. So this is running Postgres again. I have kind of an older image being run because I know that that works. Someone else might want to use a different image. We'll get into that in the future. And then I'm mounting another volume here for the Postgres data. Again, on my machine, I know this volume exists here, but on someone else's machine, it might exist somewhere else. And then more environment variables and more resources. So it's a relatively simple job, and I know that it works. I've tested this before. I'm able to run this job. So let's just start from that assumption. So we've written a Nomad job. Step 1 is done. Let's get to step 2. And let's get some basic scaffolding. So I'm going to pull down something here, this example Nomad Pack registry. So it's a repo we host within HashiCorp, and it could give you just a very basic registry to get started. If you wanted to write your own packs, this is where you could start. You just clone this template. And right now we see that the Hello World pack that we're familiar with from earlier is in here. So I'm going to clone this, and we'll start using this as the basic scaffolding for our pack. So we'll take this and we'll actually convert this from a Hello World pack into a Nextcloud pack. Okay, so I'm back here, and I've now taken the working Nomad job. I've plopped it into this pack that we got from that scaffolding, and we see that it's a Hello World pack. Let's see what we now need to change. So first, we need to go and change this Hello World name to Nextcloud. We also have some variables that are referencing Hello World variables. And then also we have this output that is specific to Hello World. We have this README that's specific to Hello World, and we have variables. So I don't want to, make you sit through all of this. So what I'm going to do next is I'm going to change the names of all of these references to Nextcloud. I'll change the name of this file. I'll delete any of the variables that we don't need. And then in the README, I will get rid of everything that we don't need. So with the power of video editing, I'm going to do that right now. All right, so I removed all the information that was specific to the Hello World job. I've replaced Nextcloud. I've renamed it Nextcloud where it needs to be renamed. I've gotten rid of all the variables except a few, and I've cleared out the README. So I think step 2 is all good. All right, now it's time to input metadata and the README. This should be pretty quick. All right, once again, through the power of video editing, this is done already. So I just dropped in a brief description of what Nextcloud is, some caveats about how you would run it successfully, I called out dependencies saying that it requires Linux and it may or may not need Consul. More on that later. And then I left the variables blank because we haven't yet identified exactly what the variables will be. I have some ideas that I spelled out here, but we'll go into that soon. So that's the README, and the metadata, similarly quick. Drop a brief description, a name, and some links to attribute the author. All right, so that is step 3. We're done with that. Now it's time to move on to step 4, identifying parameters. All right, so I've taken the working job spec and I've dropped it into the template file, but not much is parameterized right now. So I think what's important is to go through this and see what assumptions are we making about our environment that might not be true for other people's. And then we'll make a list of those, and those will be our parameters that we'll pass in as variables into this pack. So the first thing that jumps out to me is this constraint, this Linux constraint. So I might have only this constraint, but other people might have more constraints. They only want to place this job on, certain nodes in their system. So we should allow people to add their own constraints. That's one. The next thing that jumps out to me is the network stanza. So I've assumed that I want a network stanza and I want these static ports. These ports are static on my machine because they're opened up to the outside world, but on other people's machines, they might not want static ports. And actually, we advise against static ports on Nomad. So this is, again, something that we'll want people to be able to customize with the variable. So now we have the network and the constraints as our 2 parameters. Let's keep going. So now the next thing that jumps out to me is the image. I'm using the latest image, but a lot of people like pinning images. So we might want to pass this in as a variable. After that, I realized that this mount is making some assumptions about the system too. I have my data at this directory, but other people might have their data at some other directory. And so we should make this mount customizable. Same thing for the Postgres task that has its own mount and also its own path for the source data. So there's that. And then next up, I realized that these resources are custom for my system. So I'm planning to run this in a home lab. I can run this with relatively low memory and relatively low CPU. Other people might be running this for an entire enterprise, and they might want much higher memory or CPU, or they might want lower memory or CPU. So that should be customizable as well. And then lastly, these environment variables. I'm making some assumptions about the admin and the password. And also I'm hard coding in the Postgres password, which isn't good. A lot of people want to use Vault. They'll want to pass in a stanza that says, or a call to Vault saying that they want to grab that password from Vault. So that's something that should be parameterized as well. And then lastly, there's this question about whether this database task should exist in this pack or not. Now, I want this database task because I'm running this on a single node. I want this database running in the same namespace. But in the future, I might be running a database, let's say, on RDS or on some managed database service. And I won't want to have to deploy this database on my node myself. I'd just rather point to it in the future. So we can probably identify that some people will not want to run this task at all, and they'll just want to run this application task. So that's another parameter. All right, so now we've identified our parameters in step 4. Let's take a look at the list. Okay, so I've added these 2 variables, Nextcloud image tag and Postgres image tag. I give people a description and a way to find all the options, a link, and I inject my defaults as what I was using previously. Now that these variables are here, I can inject them using Go template into the template. So here, for instance, our old code looked like this. It was using a specific image, and our new code looks like this. It's using the variable. Let's test this out really quickly. So I go to the terminal, and now I can render and pass in this image tag as latest. When I do that, we see it's using Postgres latest. When I don't use the variable, it uses the default. Great. Now let's move on to resources. And for this one, we'll use a helper template. All right, and now we have 2 more variables. We have this app resources variable and DB resources. This is a little bit more complex than our other one. It's an object variable, so it takes a CPU and memory value for each. And you can see that these are the values that we were passing in before as the default. Now when I use these, I'm going to use them with this template. And so our old code looked like this, and our new code is calling this template. And it's the same thing above in the application task. So this template gets an argument, which is the database resources variable. And then you can see how it uses it. It takes the argument, it assigns it to this value resources, and then it prints out the resource stanza. And this is a nice dry way to write our code now. Next up, volume mounts. Okay, so this is our most complex variable so far. So this Postgres mounts variable defines a list of objects. Each of those objects have a lot of keys, type, source, target, etc. And then bind options has a list of objects itself. And our default is right here, and this is what we were using previously in our template. So let's look at how this is used. So in the template, we're passing this variable into the mounts template, the mounts helper template. So let's look at that. This mounts helper template, defined here, takes the argument, it iterates over it, and for each mount, it creates a mount stanza. And then it injects the values from the variable into each of the keys in the stanza and iterates over each of the bind options to create a bind option stanza. So that was volume mounts. And I'm actually just going to skip past the others as it's a very similar process. You add variables, you add logic, you templatize, etc., etc. So let's just go to the end now. And the last step we have is to test this and then contribute. This is the fun part. Now we have a fully parameterized job spec. We have a constraints parameter passing into a constraints template. We have the network being parameterized. We have environment variables being parameterized as well. Optional Consul services being passed in. And then also this conditional saying that if you include the database task, you'll add a database task, but if not, don't render a database task. And then lastly, I've added this pre-start task that creates data directories on the host using raw exec. This is optional. Again, this is off by default, but if you run this, it'll make it easier for people to use the pack without doing pre-existing setup. And that's really important. So let's test this out. Let's go to our terminal. Let's render it once just to make sure it works. Okay, that looks good. We'll run a plan. Okay, that looks good too. And then we'll do a run. And this is now pushed up to Nomad. Excellent. We'll give it a second for the images to download and then we'll check back in. All right, the images have downloaded. So we'll pop in here. We'll check out this task group. We have one allocation. We have our pre-start task, and then we have our application and database task. This application, if you remember, was running on port 4001. So now if we go to port 4001, we see that we have this login, and we gave it admin and password as the admin password. And now when we log in, it works. And now we have an instance of Nextcloud up and running. And now we just have one step left, pushing this up to the Nomad Pack community registry. Once we push this up and it gets merged, anybody will be able to run Nextcloud on their Nomad cluster with just one command, Nomad Pack run Nextcloud. So here's my pull request. I give a brief description of what Nextcloud is, and I create the request. And there we go. So that's it. We've gone from a Nomad Job to a Nomad Pack. And I hope throughout all this you now understand what Nomad Pack is, how it works internally, and more importantly, how you can contribute going forward. I really cannot encourage you enough to contribute to the Nomad Pack community registry. It's something we're really excited about. We've already had a great response so far. It's something we're going to continue investing in the coming months and years, so please stay tuned for more around Nomad Pack and its integrations with Nomad. Have a good one.